Hello YouTube, this is Sam from TIGS Schooling. In this session of the video, I'm going to actually talk about the hormonal regulation of the calcium ion. And in the case of hormonal regulation, or you can say homeostasis, maintaining of the calcium ion, we have to say that the calcium ion is actually regulated by three important hormones. Like calcium is regulated by, we're talking about the regulation, all right? Regulated by three main important hormones. That is, number one, it is vitamin D, its active form. I'll be talking about the vitamin D in detail. The second is the parathyroid hormone, PTH, and the third is the calcitonin. Right, so you have to remember which hormones actually regulate the calcium ion. It's vitamin D, the parathyroid hormone, and the calcitonin. First, we'll be talking about the vitamin D. I'll be writing things down here and we'll be explaining this picture if needed. Remember this one. Now let's get to it. Remember, the vitamin D is actually in different forms. Like if you, in the skin, it is actually present in the form of vitamin D in the skin is actually present in the form of cholecalciferol, right? And this is not an active form, so this have to be converted into active form. Like the skin cholecalciferol has to be converted into another form, which is 25 hydroxycholecalciferol, which is hydroxycholecalciferol, and which is again D3, and it is converted into this in the liver. Remember this one, in the liver it has to be converted into 25 hydroxy D3, and again this 25 dihydroxy have to be converted into the 1,2,5 dihydroxycholecalciferol, and that is vitamin D3 again. And this vitamin D3, which is the 125, this is actually the active form. This is the active form, and this active form is actually occurs in the kidney. So you can say that in kidney, the vitamin D, which was in the form of 25 hydroxycholecalciferol, has been converted into the 1,2,5 dihydroxycholecalciferol. Alright, so we got the vitamin D in active form. So this vitamin D as an active form acts on the intestine, the small intestine, and when this vitamin D, which is in active form, which active form is 125 dihydroxy D, actually acts on the small intestine, and in the small intestine it helps in the reabsorption of the reabsorption of the calcium ion. I'm sorry, not reabsorption, it's the absorption of the calcium ion. So vitamin D helps in the absorption. How it helps in the absorption? This is what I talked about, the synthesis of the calcium ion. Now if we talk about the how this absorption occurs, let me explain it now. And one thing you have to remember, that this from 25 hydroxy to cholecalciferol to 1,2,5 dihydroxycholecalciferol, there must be an hormone called the PTH. So PTH acts on the kidney and helps in the conversion of this into the 25 into the 1,2,5 to an active form of vitamin D, and which acts on the small intestine. And now let's talk about the action. So what I mean by the action, like what this vitamin D does, what the function of vitamin D. So it actually does its job in three ways. It does its job mainly on intestine, or you can say intestine, and the second part, it does its job on the kidneys, and on the third portion it does on its bones. Right, so if we talk about first, that is a major part, it's the intestine. So what it does on intestine, it actually, let me use another color. So in intestine, what happens? It helps in it increase the absorption of calcium, right? It increase the absorption of calcium. How does it do? It does it by the formation of more carbidins, the calcium binding proteins. There's a calcium binding proteins called bindins. It's a protein, and this when the vitamin D3 acts on in small intestine, it increases the amount of this protein, and this protein is actually going to bind with the calcium and helps in the absorption. Without this protein, the calcium cannot be absorbed. So what does this vitamin D3 does? It goes into small intestine and acts on the small intestine and make it to release calmidins, which actually help in the bind to the calcium, and which when it binds to the calcium, and it is absorbed in the small intestine. The one thing more it happens that it increases the formation of calcium ATPase molecules that are needed to pump calcium into the intestinal cells. And the third thing it does in the small intestine, it increases the formation of TRPV6 molecules. So what are these? These are the protein membranous molecule. They are protein membrane, like proteinous membranes. Protein membranes, they actually help in the transportation of different molecules. Like this is your membrane, and these are the protein channels, and this is your TRPV6 protein channels through which the calcium actually gets from outside to inside. So this also vitamin D3 increase the formation of TRPV6 molecules. Now if we talk about the again, if we go to the kidney, we have to remember in the kidney what it does. It increase the TRPV. Again, it's a membranous protein, TRPV, but here it's TRPV5. In the kidney, it's something else, TRPV, and it happens in the tubules, right? Tubules. So in the tubules, the TRPV5 is increased, and which helps in the reabsorption of the what you call the calcium. And the bones, it increase, like indirectly, it increases the activity of the osteoclast. All right, so this is all about the vitamin D function as in help in the regulation of what you call the regulation of the calcium ion. Now let's talk about the parathyroid hormone.